Hello, hello. Welcome to the session. Long time no see. I've been kind of busy these days with stuff, and I forgot about the channel and the commitment I had with the photo posts. So I plan to go get back to it and try to explore some new things that I've been doing recently. So, one of the things I wanted to explore on stream that got in my mind is how to extend GIO UI. So, GIO UI is a cross-platform immediate mode UI library for Go. I believe it is one of the best libraries that you can use to construct UIs on the language. So, it has a WebAssembly demo where you can run the kitchen example. You can see the selection working, scrolling, icon, the stain animation, even like some cool transformation that you can do on the entire layout. Like you can see the entire power of the UI library here. Uh, there are some example applications, and yeah, it is a pretty cool library. I recommend everyone to check out. So for today, I want to extend the library because the library misses a crucial part of every GUI software development, any serious GUI software development, which is accessibility, which is depending on what you're working, it's basically required because the company might get sued, you might get sued because of some local country regulation about the accessibility and right to work, yada yada yada, some stuff like this. And GIOY has and stacks. So actually, let us first install the let us first uh, get the repository. So if we go to contributing, we can go to, I believe it is, oh, maybe I go, not Firefox. What? No, I don't. Oh, it's mail too. Okay. GIO. I search GIOY source hot and it searched for garbage because apparently uh, search engine is doesn't matter anymore. Okay, okay, I finally found it. So let me get the read-only repo here. And let's start by cloning the repo. Bring here. So there it is, the entire project here. And to test it, we are going to clone also the example, the GIO example here. So let me go back and git clone that to maybe the URL is, I haven't cloned the URL. Okay, git clone here. Okay, now it's clone and for GIO example, we can go to the go.mod file, because we actually need to change the GIO UI to find it uh, inside our file system things instead of targeting the stable version. And for that, I'm gonna just ask AI, how do I make a Go module target a local project instead of a remote repository for testing or process? Okay, so Go, it is, oh, I just need to edit Go, I just need to edit the file. So yeah, let me go to that. So we can do, I mean, I don't think it's there. So I think we put here, so gio.ui.org, it changes to, why? Oh wait, I know why. Uh, Let me do something quite quickly here. What do we here? Uh, mm, okay, let me test it again. Okay, now it worked. Nice. Da, da. So if we test now the if we do God mod tidy here, I don't know why it's downloading this stuff. I mean, whatever. Mhm. So let me get it. So yeah, let me go to the GIO library. Let me go to the OS Linux, OS Wayland. Let me go to the OS Wayland. Uh, yeah, let me install this. So let me go here. I think there is a init function. So yeah, here. So I'm gonna just call format println test. I think there is a format here. Yeah, it has already. So we go back to the GIO example and we can run the kitchen and and you will struggle typing. So we can we'll compile this example, and if it's running the local version, yeah, it is. It printed test. So yeah, it is using the local version. This is the same application on the GIO UI uh, page. So yeah, it's same things. You can even do the transform and a lot of cool stuff. So yeah, neat. Okay, so the next thing to do it is to go and implement dbus, which is here. Okay, and there it is, the specification here. So yeah, we have here the specification of the protocol. It is basically a protocol for using for IPC, and it is used for a lot of the desktops on Linux and even BSD for some extent. And you can do a lot of things with it. Applications can expose the functionality on dbus, and the other applications can talk to another by the same interface. So for example, there is the one example, it is the Empress dbus interface, which is interface to control uh, media reproduction. So you can pause, play, change volume, change track, a lot of other stuff that you can do it. You can also do but I believe theme. I There is an interface to change the appearance of the desktop. So yeah, there's also that. So it is dbus, it is arc, free desktop, portal setting. Here, arc free desktop appearance, color scheme, new, no preference, preferred, dark appearance, light appearance. So yeah, there is a lot of things. The portals are exposed as the bus interface. So yeah, it is very useful to implement the bus specification. And I plan to do it on Go, entirely on Go. So yeah, that's what we are planning today. So basically, to implement the specification, we are going to edit the GIO. And what we are going to do is we are going to create the library code inside, I believe internal is good enough. And I'm going to write dbus. And so we are going to have dbus.go and dbus test.go. What it is to make to implement and to test the implementation. So we are going to test it Don't know why it doesn't open here. Press again internal because it's okay, it works now. So on dbus, the dbus specification exposes a socket, a Unix socket. So if we go there and do echo sys xtg session, I'm not session with it is runtime there here. And if we go to, and if you do ls here, we are going to see a lot of things. One of them, it is the what it is. We can see the ATX SPI, which is accessibility interface. We can see the Wayland socket. So we use that to, it is the, if we want to make like a native Go uh, Wayland wrapper, it is entirely possible and maybe even preferable than trying to do the bridge with Seagull. But yeah, I believe it is this called Buzz. I'm not sure. I believe it is. So yeah, if you go back to the website, I think there is a thing. I think it only calls about the message protocol here. It doesn't talk about how to connect to it. So maybe I should go back one. Maybe if I go to the introduction and I want to know where it is, where I can find the socket. Uh, okay. There is also a low-level C binding, but I am not interested in implementing low-level C binding. I want to implement it entirely on Go. Maybe that's an insane idea, probably, because I don't think it is finalized protocol. I mean, I believe it is, but basically finalized because there isn't any major changes in the last years. So yeah, I want to know how can I get the address. So here, the bus. There is a Unix path. Oh, maybe there is an envar that exposes that. I'm very sure about it. So echo, there is one. Isn't it the bus? The bus session bus address here. So if we go to the bus session bus address, there it is. This is the Unix path to the thing. And so we basically need to connect to the socket to to send the messages and get responses to it. So we are going to yank this entire thing. Wait, I didn't want to So we are going to write a type connection, which is will be a struct, and this struct will receive a scene, which will be a net column. I believe it is column. And we are going to make a new function to connect, which will receive a pointer to a connection and error. So we are going, firstly, we are going to give the, to get the envar. So envar, we are going to get by os get env. We are going to get the envar of the bus session bus address. And if length of envar it equals 0, then it means that return new format, maybe not format, or no envar. And we are going to define the errors here. Error no envar, and basically errors new. And we are going get here. Maybe I'm going to put it on ticks or backticks. I don't. I'm thinking it is backticks. I don't remember. So yeah, we are going to define a new error, and then we are going to now parse the error. So, I mean, not parse, but we are going to check. Actually, we can check instead of knowing var, invalid and var. Instead of changing no, we changing valid. So we can check if the length is less than 7. I mean, yeah, I think it's an okay. I mean, we can always put a to do to check it to do the job better later. So yeah, because what we are going to actually do, it is to get the Unix stir, which will be the envar to the first 4 characters. And if it, actually we can just compare this directly. So if envar first 4, it is not a Unix socket. And we're going bus address has valid connection. And we can even do a funny thing, we can wrap an error and we're going to pass the string. So we are going to do the error invalid connection and the envar to slice of 4. So the address will be basically the path, we will basically envar, which is skipping the semicolon and to the rest of the slice. And we are going to use this to get the connection. And I also think it returns an error value. So we are going to add net connect. We are going to pass Unix and the path. We are now going to we check the error. If it's not new, we are going to return error connection failed. We are going to wrap two errors in this message. Maybe not maybe not forget the quotes. Error connection failed. So plus address failed. So yeah, and if it is successful, we are going to basically return connection with the connection and nil for the error. So yeah, I'm going to write the test. So package dbus test basic. So what you want to do now is to basically get the connection by connect if also we need to get testing the I can't forget this. So if error is different than new, we are going to fail the past, and I don't remember exactly what methods do we have here. We have fatal f. So we actually have fatal ln. No, we can just pass error here, and yeah. So you basically can we can test it opening another terminal window. Maybe it is Gioui Robson Gioui and it is internal bus. No, not even that. Go test internal bus, and it failed to compile. If I do this, and there's not a function called connect on net. Oh, it's dial. It is dial. Oh, it is an interface. Oh, okay. Oh, wait, it has like a path on it. Okay, so do correct path stuff. So I need to skip four more letters, so 10. Okay, so we had a program that successfully opened the bus socket. Nice. So now we can start looking for the messaging stuff. So there is a lot of things to go about the bus, which is uh the there is the address and okay, the object model. We have one end of any exchange on a bus will always be communications, and thus then the bus parlance is called an object. An object is created by a client process and exists within the context of that client's connection to the bus. The object is a way for the client process to offer its service on the bus, but one client may create any number of objects. The bus imposes an object-centric view of communications, where any message carried by the bus is one of the three kinds. Event sends to objects by client processes, replies to requests, code going from an object back to a request process. One-way messages emanating from objects broadcast to any connected client that have registered an interest in them. So yeah, this third point is how like an application can listen to theme change for the appearance change in the desktop. So that's how they have the cool appearance transition between light and dark mode. That's how applications can do it on Linux. And I guess on Windows and macOS too. So there are signals. Mhm, and interfaces. Mhm. We have it here. We have message ordering, activation. Okay, so this is like a general overview about the library. I'm going to look at the documentation. So maybe it's kind of messy. So yeah, the Bus protocol is frozen as of November 8, 2006. Okay, it's frozen for 20 years, basically. So yeah, I guess it's pretty safe to implement to have a pure Go implementation of it. So we have the type system. To unblock the dbus protocol does not include type tags in the marshal data. A block of marshal value must have a no type signature. Okay. A type code in an ASCII character representing the type value. Because as characters are used, the type signature will always form a valid ASCII string. A simple string compared determines whether two type signatures are equivalent. Mm-hmm. Okay, so we have these types, which is uh White's assigned 8-bit integer is a boolean and is assigned to complements basically a 16-bit integer unsigned, signed, unsigned. Okay, D is I754 double precision floating point and age. It is a 32-bit integer, but it is specific to representing a file descriptor. Okay. So can have some stuff with it. We have also other types like string, object path, and signature. There are container types which are represented by parentheses, represent a struct. There's also array. There is variant. Oh boy. Yeah, this is going to be kind of messy because it can vary the stuff to return. And there's a dict entry. Okay. There are some reserved characters. Okay. Debus defines the marshalling format for this type system, which is using debus messages. Okay. Oh, there's also the issue of alignment. This message is not a multiple of 4, so yeah. So yeah, it, so the penny is always 32 bits, maybe. Oh no, it depends. Of course, it depends. So if we use a struct, it is 8. If we use a dict entry, it's also 8. Or not. Okay. This is a quite interesting protocol, so to speak. Okay. There are error names. Mhm. Oh. Okay, so I know there is a way to send notifications through. I think notification system on Linux works on dbus, so maybe we can start by implementing notification pushing. So maybe we can push notifications on the system. So let's see. So let us see. Firstly, let's do some work on the protocol type because it seems like there is like a message. The structure of the message is where is there is a header and a body. So the length of the header must always be a multiple of 8. Okay, so it's always aligned, 8 byte aligned. But the body doesn't need to. Okay. The maximum length of a message, it can only be 128 megabytes. Okay. Holy, going to send like an entire image on the socket. So the signature of the header is here. So it receives 4 bytes, 2 Uint32, an array of struct which has a byte and a variant. Oh, where the byte? Wait, an array of 0 or more header fields. Okay, so basically we can extend the header more, I guess. Okay, so the first header, it defines the endianness. The second byte specifies the message type. The third is some flags. The fourth is the major protocol version. Okay, so maybe it's going to always return 1. Leading bytes of the message body starting from the end of the header. The serial of this message uses as the cookie. This must not be 0. Oh, okay, so it's like a random number. It's a number that the application generates before sending and attached to it to distinguish between multiple requests. Landing byte in bytes of the message body starting from the end of the header. Okay. So message types can be method call, method return, error, and signal. Okay, because I also think that an application can also expose the an interface, right? So yeah, there are header fields. Oh, the I guess it is the struct in question. So 0 is invalid. Okay, 1 is the object path, the signal, oh, the path, the interface, the member, the error name, the reply serial, the destination, the sender, the signature, and the Unix FDS. Okay, so these four are optional. And for method calling, only the path and the member is required. So we need to specify the path and the member. So I guess we can test it right now because there is the bus send. There's like an interface. I can do it. So for example, let me search it here. The bus notification. So there is uh there is this uh destination object net path. So it is like org free desktop notifications notify and hello. See. Okay, direct path was not valid. Okay, so how would I send like a org free desktop notifications? There is get capabilities destination object path was not ready. Okay, let me see. Is there like maybe there is a menu for the bus and why it's loading. Okay, it opened the terminal. I don't know why. It opened the manual page. Okay. Hard free desktop. So basically I need to go like this. Mm, or or free desktop notification. Okay, okay, it returns successfully. Okay, what the hell happened? Let me open the mess the thing again. So there is sample object name, and there is the example interface and example method. And we can call the parameters here. App name. Okay, so we need to pass the exact comments. So string hello, and let me put it on another window temporarily. Get it here. Maybe it's like this. Put it not. I don't want this. I want this. Okay. So I want to get the Gioui 0. I want to get the string by Tom summary. This is a test. Uh, how do I represent like a list of stuff? So it is. Oh, it is. It isn't like string. Uh, there it is. There is hints. So hints will be an array. So array of a type. So this will be string and the value. Oh, I see. Like this. And enter 2 minus 1. It happened nothing. So I need to see the manual better. So an example invocation. So destination will be arg free desktop example name. and a sample object name and the example interface and okay, this is so confusing. Let me do something. Let me ask uh PLLM because I actually before let me test because there was a thing here to write on the destination. So mm, doesn't matter. So yeah, let me try to see the protocol. How do I call this? Oh, it is notifications with a capital N. Oh, oh, nothing. Okay, it is doing stuff, but the calling example that I'm trying to do, maybe it's not correct. So let me go here back again. Arc free desktop notifications will own an object with the path arc free desktop notifications. Okay, maybe dbus send. Oh, there's a oh no method. So it's saying there is a invalid arc free desktop notifications notify. I don't believe it. Oops. The developer console by accident. And what was the other thing? that I saw here. I mean, I'm almost certain that I've typed correctly. Invalid method call. So, okay, let me uh, visualize this first. So to make a call, it seems like it only needs like to be in order. Hmm. Okay. Non-users. So mm, so the destination would be free desktop. Maybe that. Mm, oh, okay. We okay, now we are calling to the correct method. Okay, so the structure seems wrong. Sussa, su, sussasi. Wait, so that's lying. No, it's not lying. Oh, there's the. Oops, it is actually wrong. That's the test. And then there is the dict. So there's a dict, and the dict will be a string variant. And erase. Malformed dictionary. Oops. Variant sub missing variant subtype specifier. Oh, variant subtype specifier. What is that? Variant inter2. Okay, how? So there's a date of string variant, and we have to specify notify send it of, of string variant. How? This is not real. This is not. Oh, wait, I'm looking at on the other screen. Sorry. No way it is on the manual. What is the string? Does not permit. Oh my god, why? Okay, we are going to write this and go. We are fucking going to write this and go. I don't care. We are going to write this and go. So, uh, we are going to make so let me make this. Hmm. So let me make a function here, a method to be more precise. And we are going to make notify. And we are going to pass message string. Okay, so firstly, we need a way to write the header. So so write the header. Uh, uh, you pass the format. Okay, so the socket. We are going to use the native endings of the device. So there it is. Okay, encoding. So binary name So native agent it is. So we're going to make a string. Maybe there's a better way to optimize this. So if Indian is equals middle Indian, we are going. Okay, so first of all, we are going to have a buffer. So can I reset? Yeah, okay. I'm going to reset the buffer, and it is the engine is of little engine. I'm going to write the the first byte specified. Actually, we don't even need the engines of this thing already because we are going to only write the byte. So if we go to the basis format, we are going to write a byte, 3 bytes, two. So the first byte is going to write an L. Okay, lowercase l. So I think there's let me uh, yeah. Else we are going to write the capital B to indicate beginning. Okay, so the other byte to set is the message type. So message type, we're going to write one. Let me call this notify header. Uh, let me get the third byte, which are the bitwise R flags. Okay, no reply expected. Okay, maybe we can pass that because I don't know if I care about it. Actually, nah. Let me have the return type. So I'm gonna not pass any flags. The other byte is the major protocol version, and that we know that's one. we can basically write on one thing here. And we are now going to write the the body length. So we need so we are going to write binary, native, Indian, um, oof, really, let me write like an array, array of eight positions of bytes, only because of testing. Sudo remove array. And we are going to put on buff Gioui 32. So buff 0 to 4. We're going to put number uh, the actual length. And we are going to the other thing we are going and then array on something to identify. So let me put it 6, 7. Do uh, gener generate and start request 15. Request ID. And the other thing, it is an array of 0 or more header fields. Okay, how do I write an array? Because I think I need to write the size of the array, right? So marshalling containers. So I want to see like the array. Okay, so and we need to marshal the array having a the first thing is it is the length, followed by alignment padding of the aligned powering of the array element type. Okay, so in this case, it's only gonna be 0. Yeah, this is the array. Okay, maybe we actually want to separate these methods to facilitate the writing of stuff. So for example, we can actually refactor this to be uh, right u32, and then we can put it here, and we can put var buff uh, right, and just forget. So instead of here, we can do C, right, viewing 32, and we are going to pass 0, 6, 7, and length. Oops. So yeah, maybe that's easier. What it is called again? The header fields. Okay. So there is the header. Actually, 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 the header fields are the fields length. We are going to write because this is a array of struct of byte variant. Okay, so just no, no, it's not good. So I need to write now the header fields. So the array at the end of the header contains the header fields, where each field is a 1 byte field code followed by a field value. A header must contain the required headers for its message type, and zero or more of any the optional header fields. So it is a of zero or more header fields. Okay, so let me make a maybe this any won't work as won't work as well. Okay, so so it seems like there are multiple header fields. Okay, so I get it, I get it. So to marshal the container, so I need to do structs always aligned to 8 bytes. So okay, I mean on the wire. Doesn't matter here at the moment, I guess. No, it matters because we are marshalling the types. Ooh. Noise. Mm, um, eight. So okay, there. So the buffer. I mean, this will have a big buffer. I mean, this won't, but like, okay. So length, let me calculate the length of the value. And if L of 8 different 0, then we are going to increment to the remainder, so it stays aligned. And we are going to create a buffer of byte, nice little byte slice with the specified length. Actually, the string container needs to be okay. Okay, so to write a string, you basically have to write the okay, so we basically have to write the first thing we have to write it is the length of the string, which is L, followed followed by the string itself. So IO write string to oh, wait. There is a function called write string on IO. Okay, there is. It writes a string if it implements string writer. I believe it does. I believe it does. So okay. So write the uint32 and it's going to write the string and um, it's going to write the terminating byte. Because I guess this doesn't count the no terminator. No terminated. Actually, not. Actually, actually, no. It's because it's going to be zero anyways. It's zero initialized the array, so it doesn't matter. Okay. Um, already zero initializes. Okay. Actually, no. Maybe you can just write the path. Yeah. Maybe it works. I think it does. Because it's going to write the buffer. If its buffer is empty, it just won't write anything. Yeah. So instead, hmm, rename rename this. So yeah, there's the right header field path, right header field viewing 32, which will be oh yeah, I need to write gonna write the byte. Okay. Byte. Mhm. Oops. Oh wait, just as an analyze, so maybe this will work. Yeah, it does. Okay. And we will fill the padding. So 1, 2, 3, 4, 5, 6. It is the padding. Oh wait. Mm, I guess this is the padding. So the thing I only need to send is the path and a member. Okay, so we're going to write two, and we're going to write C, right, the field path, which will be one, and will be mark we pass up notifications. To sim or a desktop notifications notify. There are two notify headers. Oops. Just three. And now I write the parameters. Okay, let me write the other methods. I think it will be the same these days, but I expect the alignment to be 4 instead of 8. Actually, it, the lane is without the no termination. Also, it is so strange because we need to no terminate, but we also sent the lane. Like, what? Sorry? Excuse me? Like, let me say it again. Yeah, we need. Yeah, you insert to became the string length invites excluding terminating null part of null on string of data of the given length followed by a null, a terminating null byte. So it needs to be null terminated. Oh my god. Oh my god. No way. No way. It still needs to be null terminated despite sending the link. What? Sorry? Maybe it is for avoiding like uh maybe it's because it avoids like mm, vulnerabilities. Maybe it's because of that. So yeah, maybe I shouldn't make fun of it. Maybe it actually makes sense. But yeah, I'm not going to judge. Okay, so you enter string, you enter to string, 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 array of string. Hints. Okay, so let me write the payload now. Uh, what is long with it? Oh yeah. Oh, uh, city undefined. Okay. What is complaining about? Okay. So now we can write the message. CP write. We are going to write some stuff. So the thing we are going to write is the just gonna copy paste this. Okay. So here, as I believe buffer the can do the write interface. Yeah, we can do write string as buffer here. Yeah, perfect. One of this. We can do GIL1 test. And the other check let's see 0. This can be an empty string. Test as notification. Okay, now it needs to writing an array, we are just going to write 0. So yeah. Um, empty hints. And but I think he needs to write 2 times like padding. 2 times like padding and in the expired timeout, which I'm going to have -1. So it's going to write a notify header. And it's going to write the buffer. I think this works. I think this works. It should send a notification. So time for the truth. Oops, I think there's the other window here, and we are going full test internal bus and nothing. Maybe because we need to flush the connection. Okay, how do I send the connection successfully? Uh, I mean, I should just flush, right? And just uh, I know that you can. No, I think can. Mhm. Okay, so I'm having a question on how to treat the the reads, because I think it should be working. I think. I mean, I'm not sure. I may make a mistake, but it should be working. And I'm very confused. Okay, so how do I write an array? Mm, Okay, this is harder than I expected, as always. So the there is a thing about the type marshalling that I think it needs more rigorous testing. Because I feel like it should work. Mhm. Oops, I think I converted everything by a single case by accident. Okay, there is actually like a correct signature that you need to provide. It's not that simple. I I thought that I could cut some corners, but yeah, apparently we can't. So is there like a simple? I mean, I don't think there's a simple interface. I mean, we need to also, I didn't want to implement the response parsing, right? Also because I wanted to implement like a loop. So I think that would loop to wait a new connection, parse the stuff, and yeah, we do. So yeah. There was quite a long string. I think I started to understand more about the bus, how the arguments are parsed, probably. So yeah, I think we need to write tests. Maybe on the next string, we are going to write tests because unfortunately I couldn't write a response, but I think if I change the the thing, so if I instead of calling notify, I call cat capabilities. It okay, this actually returns the stuff, and it tells like a lot of the other stuff. So yeah, it returns an array with body markup, actions, icon static, X canonical, private synchronous, instance stack tag. Okay, so it returns the capabilities of the current notifier, which I think in this case I'm using Mako. So yeah, this is cool because the the library can treat these as the library can treat these as some other stuff. I wonder if there's actually like, because I know there is the GIO, the GIO stuff, but I think it has uh I think there's GIO X. So GIO X. So the GIO X has a lot of stuff and it has notify. Okay, so it actually has notifications. I wonder what it uses. It doesn't have support for macOS. Support is preliminary. Okay, so macOS, iOS, Android. It doesn't have for Windows. Okay. Okay, so actually, let me, where it is the JOX repository. Mhm. Okay, so there is notify stuff. Oh yeah. Um, I think I want to get like the debug stuff on the car. Basically because it needs for accessibility, so there's no escape. You can escape for that from that. So yeah, you absolutely need debug. And but I wonder if it's like, let me see how, because it needs to, for the notification stuff, it needs to implement debug unless it does, it links with it. Oh, it actually uses go debug. Wait, but go debug is, it's BSD2 clause. Excuse me? The BSD2 clause, like it, it isn't necessarily public domain. The distribution of source codes must retain the above copyright notice. I mean, the borrowing fund must reproduce the above copyright notice. Ooh, that is bad. Okay, it needs to. Maybe this needs to replacement. Okay, this is quite bad, to be honest. So yeah. Okay, so we need to replace this stuff. But I wonder how to expose this later. I mean, I want to get this debug thing working because I'm going to test it. I'm going to implement like the notification stuff because I want to test it later for the because I want to use this for the accessibility uh, stuff on Gioui. So yeah, that's why I'm implementing dbus. I want to implement accessibility on Linux. And as accessibility on Linux, implement the ATSPI. Uh, Maybe not this documentation. Yeah, ATSPI 2, which provides content for screen readers. So like a screen reader can understand the application. Another thing that should be fun to do also is to implement iAccessibility too. iAccessible too, which is a window accessibility interface for Windows that the Linux Foundation uh, maintains or owns, which is kind of funny. So yeah, maybe this is also like a fun thing to implement also. Because I tried before to implement the UI automation, but there are some limitations to how Go callback, how callbacks in Go are handled between Windows and Go doesn't support callbacks with floating points. So yeah, and um, it only supported without with Seagull, but Seagull uh, not having Seagull Windows for GIO is a hard requirement. So yeah. Anyways, I kind of enjoyed the session. I learned a lot of how the dbus protocol is parsed. Like, where is the specification here? Yeah, no, this page is the specification. So yeah, there is a lot of stuff that I learned. I learned how the headers are, how the types, some part of the serialization, padding, and yeah. So I think on future stream, we are going to implement dbus marshaller and unmarshaller. And maybe because I think like if you go to user share dbus interfaces, look at this. There's there are XML files, and if we go, sorry, if we go to the XML files, so let's get the org free desktop notif. There's network manager, but like let me get the isn't there like Get the portal. The notification. Look at this. Also, actually, look at this. There's actually an XML that defines the interface. So the thing is, you you can a fun project that you can absolutely do is you can implement a, a scanner that generates Go source code from the XML definition. Because this thing, so it can parse like both the request and the response. Yeah, you can do the marshalling and marshalling of the request and response, and also of the signals, which is awesome, really awesome. So yeah, I go to user share plus one. And if I see there's the accessibility service, the interfaces, the services, the system services, system D, session system. Okay, it is the interfaces, but it only has the portal um, interface, which is funny. So if I go search for um, the XML, isn't there like a an XML of that? Okay, this is quite weird. Yeah, this is quite weird. Is there like a package on Arch that I can install later? So like the dbus. Okay, there's actually some dbus broker units, dbus docs. Oh, dbus docs aren't installed. Let me see. And if I see like I see, so the dbus docs aren't installed. So wait a second. I'm actually gonna install the docs here because I I wanna see how it is if it has the XML files on it. So yeah. Uh, this, let me close this. I mean, it would be very cool to implement like a dbus, to have a dbus implementation on Gioui, which is on the car itself. Okay, so there are the interfaces here. Oh, it has two files, the implementation and the actual. Oh, it doesn't have it. Okay, so where does the new user source, no, user local share, no, main dbus. User share the bus. So it's funny because it doesn't have like a notification XML. I mean, what does it even installs? Wait a second. Give me the command. KOL. So where do you have stalled? It was box. User share doc dbus. It's only the HTML. Oh, okay, just HTML. Doesn't have any protocol specification. Okay, okay, sure. Okay, so I'm gonna stop right here. Maybe on the next stream, I'm going to, I plan to implement the write, probably the reader and the writer for the types, and maybe some code generation tool to generate the Go code from the interface definitions from the XML, although there is none in the case of not the notification, but I think there is for the accessibility API. So if we go to user share E+1 interfaces, uh, wrap. Oh, I think it has. Doesn't have? Bro. No, there needs to have. Okay, anyway, I'm gonna do this later, maybe on another stream. So yeah, thank you everyone for watching, and I